Hi, I'm Stephen Wiggers and welcome to the Global Azure Bootcamp. I was invited, or I submitted a session to CloudGen, which is the Verona user group. I submitted the session, Let Systems Communicate Using Azure Integration Services. So this is a story about system integration. Okay, so I'm Stephen Wiggers. I work in the Netherlands at HSO, which is an ISV, working with companies implementing Dynamics 365 and some other Azure related services and capabilities. I specifically focus on integration. So this means integration with Dynamics 365 and other systems. I have a GitHub. You can find some of my presentations and stuff there. And you also see my LinkedIn profile. Okay, so what's the story outline? So I will talk about integration. I'll talk a bit about architecture, technology, of course, some real world cases, best practices around system communication. I will also talk a bit about Power Automate, how that reflects and fits into the integration story, the market. So how do these services relate to their competitors, and some takeaways. Okay, so what I like to do first is talk a bit about the Tower of Babel. So this is a picture of Peter van Breugel, which is a Flemish painter in the 17th century. Depicts the story, or talks about the story where people were roaming the earth and basically came together in a town, build a city, but also wanted to build a tower to reach God, at least go to heaven. God thought, that's not a good idea, so he kind of interrupted that by let everyone speak a different language. And in this case, it led to the fact that the tower could not be completed and the people could not reach heaven. So it's kind of basically the story is. And the moral of the story is, or kind of is an explanation, a biblical way of, why are we all talking different type of languages. Similarly, if you look at systems instead of people, with the rise of cloud, Salesforce being one of the first software as a service vendors providing a CRM capability in the cloud. Many others followed suit. You have, of course, the cloud platforms like AWS, Google Cloud Platform, and Azure, of course. But there's also tons of SaaS systems available, which are listed here. ServiceNow, SAP has a version in the cloud. AFAS, which is a Dutch company doing finance, Workday, and so forth. And what these systems basically give, all these systems together, can either be something that helps in your finance process, HR, field services with regards to IoT, storage, ticketing. Many of these services combined can support you in your business processes, or at least for large enterprises. Which means that those systems need to exchange data to support that process. And if you look at the application landscape, so many of these systems kind of have, you could say, relatives that were on-prem. So they were like the first generation or maybe second generation of systems that were on the cloud next to mainframes, but they're all resided, within their own data center. Or maybe they had to communicate with other systems also on-prem using FTP or other type of protocols. And then with, having the cloud available and some of these services were available as software as a services, you kind of also saw this hybrid kind of mode where we are kind of still in today, when you have systems on-prem, but you also have systems in the cloud. And then going forward, all these systems, many of them already are in the cloud, and presumably all of them eventually will end up being, software as a service, or maybe they're a PaaS type service, or the service is inside a virtual machine. But basically we're going to completely cloud maybe in the end of the day. Maybe there's still some appliances with edge devices or stack device appliances that still you have kind of your data center on-prem, which means that it doesn't have to be connected to the internet. But this is where we are gearing towards. Then if I look to integration itself, when systems were still on-prem, you had all types of brokering products. Microsoft provided BizTalk Server, which is a brokered product, allowing message exchange and information exchange between those systems on-prem. Going forward, Microsoft also evolved BizTalk Server when Azure came, bringing some adapters and capabilities to also connect to services or like Logic Apps or other systems with their adapters. And then going forward, you can also have all your systems supporting your business processes, everything in the cloud, And then you need some capabilities as well. And those are listed here with the Service Bus, API Management, Logic Apps, and Event Grid. Which brings me to the integration technology. So what's there in the Azure platform? Well, as you already saw before, Azure Integration Services. So you got Logic App to create your business type of flows and connectors to connect to systems and bring data from A to B in a certain sequence. You have API management to support your borders of your integration or have this intermediate capability between your services and systems and so forth. And you got a service bus to connect systems, but in an asynchronous way. And similarly, you have Event Grid, which was the last part added to this integration services, allowing you to do this near real-time processing using a managed capability of your events, and I will dive into that as well. These combined are all these services available in Azure. They're standalone services, but Microsoft kind of bundled them together and mentioned those as these are our Azure Integration Services. Okay, so let's look at some of the capabilities that these services offer. So I will just go through 4 of those services that combined are the Azure Integration Services. So one is Logic Apps with its connectors, allowing you to connect to Salesforce or many of the other SaaS systems. You can connect to all kinds of Azure services. For the API management, you can connect to some of the APIs and consume those with an API management connector. And even through an on-premise data gateway, you could connect to services which are on-prem. It leverages the relay, which is a capability of the Service Bus, but it kind of drives into the connectivity on on-premise systems. And even if you have a self-hosted API management, because you can self-host that capability, that you can even connect to services that are on-premise as well. It also allows you to, like what's stated here, build smart solutions, leveraging the cognitive services. So through connectors, you can build up this integration with cognitive services, supporting your AI or a type of capability you like to offer to your customers. The critical part, or the thing that really stands out with Logic Apps, are all their connectors. So Microsoft has built hundreds out-of-the-box connectors to all these systems, protocols, etc., allowing you to do hybrid connectivity. All these connectors are kind of wrappers around APIs available, inside Azure, on-prem, anywhere else that Microsoft kind of wraps around those APIs and offers those as connectors inside Logic Apps. And even if there's a connector not available, then you can even build your own custom connector, accessing REST or SOAP APIs, even on-prem services. And it's simple, just a service allowing you to go through a wizard where you can say, okay, I want this endpoint, I want TS operations, and I want to apply this type of security. And that's what the custom connectors can do for you. And if you don't want to go through those process, either creating a custom connector or using any other connectors, you can also simply create a proxy of your API in API management, and then through the API management connector consume those APIs. Then you simply delegate API management, or you delegate the connectivity to API management. Okay, so how does this component architecture Logic Apps look like? So I find this is an interesting part of Logic Apps that I think you need to know as well. It consists of 4 components. So you got your Logic App resource provider, you got a runtime, you got your connector manager, and a connector runtime. So one deals with the connectors and the other one deals more with the process, your workflow, which you create as a definition inside the Azure portal or on-prem in Visual Studio or Code. So the Logic App resource provider reads the definition you create and decomposes it into all kinds of tasks that are being done, or at least they're being executed by the Logic App runtime by distributing those to all kinds of parts within the your data center, basically. Then you got your connector manager, which all deals with those connectors, security, token refreshment, etc. And the runtime interpreted basically that open API, which sits in the background around the connectors and looks at it. Okay, I understand this API. So what you create with Logic Apps is just it's workflow. So maybe you know Windows Workflow Foundation, that's all code. And you can also do durable functions, and then you can have your code as workflow. And this is more visual. This is kind of with a designer, allowing you to drag a trigger, which triggers your process. You know, always need kind of a trigger, followed by one or multiple actions. And then combined are your workflow. And as you save this, then you have your workflow definition. And if you look at the code view of a logic app, you see this JSON language, which is kind of a domain-specific language for logic apps. And what it does, it describes completely your process. So a trigger runs after, or at least a for each runs after a trigger, and the complete message runs after the for each. This is the way you have to look. It's an inverted graph of all these activities. And basically, these activities are tasks. And one of the first tasks that will execute is when a message enters the queue. Then the peak log takes place, so you get this on message. And then the workflow orchestrator kicks in. And this resides inside the data center, and it will execute some tasks for each. And in parallel, all these SQL inserts will take place. And then there's another task completing the message. And then your workflow is complete. So this is how this workflow engine works inside the Azure platform. And it's all about tasks. So there's no thread management whatsoever. It's just, it interprets like I have this first task, a trigger task, followed by many other tasks. And this will be distributed by this orchestrator to all the data center servers where they say, okay, can you execute this? No. Okay, can you execute this? Because there's always an at least one time guaranteed execution. It will try that. And by default, it also has some retry policies when it's communication with other systems. And if there's DNS issue, throttling, or 500 responses, it will try it again. By default, 4 times every 20 seconds. But you can influence this as well. And then going forward, and this is more about hosting. And I think this is interesting about logic apps as well. So you can either have it as a multi-tenant kind of, you have it in a data center, but everyone is on the same type of runtime. But you can also, like application services, say, okay, you have this application service environment. You can also do it with integration. So I want to have my own compute. I don't want to share resources with other customers or consumers. No, I want my own runtime. Which means that you have your own logic app runtime and a connector runtime. The logic app service, which is this consume model, is serverless, as in you pay as you go. While this integration server environment means that there's more infrastructure that has to be provisioned, and then it's yours, and then you have this upfront costs, which is a bit higher, but then you have at least a consistent time of cost. It also supports some enterprise features with VNets and express routes. So when you want this isolated environment and when you want to have it more isolated and secure through VNet support, then integration service environments is the way to go. However, there's another option. It's currently called Logic Apps in Preview. And that's more like a single tenant version. So you have the shared runtime, you share it with everyone, you can have it dedicated, but you can also have Logic Apps as a single tenant, like this is my own environment, but then you can have it on the app services runtime. So it means it supports containerization, which you see in this picture, and it's either stateless or stateful. So you have those type of options. Like I said, it's preview, and going forward, it will become a GA somewhere, I don't know, maybe in the next couple of months. You can also host it in containers, meaning it can run on Kubernetes, which can also mean it can run in other cloud environments where there's a Kubernetes cluster, or even on the edge. So there's a blog post written around all these options by a former colleague of mine at Coded. So that's why you see the URL here. So it's definitely something to check out if you want to know all these hosting options. Okay, so that's it. This is all about logic apps. Similarly, you have this Service Bus capability, which was one of the first services that was available as soon as Azure was GA'd. Somewhere in 2010, you already had this messaging capability. Back in the day, it also had this BizTalk Services name, but now it's called Service Bus. Managed offering for messaging. So similarly, you can compare this with Microsoft Message Queuing on-prem, that kind of capability, or RabbitMQ, some of those queuing, but this is a managed service in Azure for communication, asynchronous between systems or applications or services. It has entities like relay, queues, topics, and subscriptions, which I will dive into in a minute. It enables this hybrid connectivity because with libraries like a .NET library or maybe a Java library, it's also supported. You can write messages to or read messages from a queue. It's compliant to some of the other protocols like AMQP, and it supports this first in, first out decoupling and transactions. So Don't compare this, or at least, you have storage queues, which are simple queues, but it doesn't support Vivo, deduplication, so all those transactional stuff and those capabilities are not in the Azure storage queues. Those are just basically simple queues. And like I said, it has 3 entities, so this is more to support synchronous communication, going back and forth, which is called a relay, which is also the underpinning technology for the on-premise data gateway. So I talked about this, logic app enabling through the on-premise data gateway communication with on-premise systems. And the service relay is basically the basics for this. Then you have queues, allowing one or multiple systems sending messages to a queue, and then one system takes the message off the queue. You cannot have multiple systems listening to one queue because that means competing consumers. It's not something we really want, although it's possible. You can have multiple senders and receivers sending messages and taking message off, so you can also have this store and forward type of capability. And then if you want to have systems sending messages to multiple other systems or based on subscriptions or filtering, then you can have a topic. So you send a message to a topic, and then based on certain filtering subscriptions, it will end in certain subscriptions. So you can have one message sent to multiple systems. While with a queue, it's more like many to one. At least there's one consumer in a system. But if you want to send a message to multiple systems, you will use topics. And that's all to it with regards to Service Bus. And then you have Azure Event Grid, which is a different type of service. So both of these services, Service Bus and Event Grid, are based on this pops-up mechanism. So you send a message and then someone takes the message. With Service Bus, it's push and pull, while with Event Grid, it's more a push-push model. Still, it's pop and sub. But it's more about eventing. So it's more about event-driven reactive programming that it supports. So it allows events consumption of Azure and non-Azure resources. So I'll dive into that as well. And it's more like you can have one or multiple systems respond to those events. They don't have to, but they can. And then they can react and do something subsequently. And I have some example of that as well. It's more lightweight, it's low cost. It sits in some of those services that support Event Grid. So those are listed here, some of those, like subscription, resources, IoT Hub, Service Bus. Those all support this Event Grid. It also supports the fact that an application can send an event to an Event Grid topic, or even cloud events, which is a cloud native compute initiative about cloud events. And I'll explain that in a minute. All these sources can send an event subsequently to one or many subscribers, which could be function as an event handler. This could be a logic app, all using webhook mechanisms. You can push events forward and buffer those in event hubs or storage queues, or you can even have other services respond to those events. It basically is a managed service, so it's either sits in those Azure services that support Event Grid, or you can have a custom topic, and all those events are being sent to this topic, and then you can apply some filtering, similar to Service Bus topics. So you can say, okay, if an event comes from this type of source, like storage accounts, and a blob is being created in a container, then I'm interested as an event handler. And you can even do some fine-grained filtering with a prefix and a postfix or suffix, like saying, okay, in this container, I'm always only interested in the JPEG file. The prefix you can even make some control. Okay, I only want the JPEG file from this specific container. And the concepts around Event Grid are pretty simple. An event happens. Those happens in those event publisher, as you can see on the left-hand side. The event publishers is, it's where the event took place, and it will send it to a topic. So all those event publishers will send it to a topic. And then the subscription is the subscription to those events. So how you want to receive those events, webhook mechanism, or push them to an event hub, like I said. And then you have the handler that reacts to those events. There are two types of schemas around events. It's either the proprietary schema from Event Grid itself, which is listed on the left-hand side. It has some properties and the data element, which contains specific values from the source itself. Similarly, You have the cloud event schema. So this is non-related to Microsoft. This is more like a cloud native Compute Foundation initiative, setting an industry standard around events. Similarly, it has same type of properties, and again, that data element containing the object unique, specific, source specific properties. And this brings me to the final part. So there's eventing, there's messaging, there's a logic app providing you connectors and workflow type of capabilities. And then you have this managed services that enables you to secure APIs, but also secure HTTP predicate logic app, for instance, or functions. So it's this facade kind of control, which could be kind of the boundary around your even integration logic. But then you simply delegate some of those those type of quality attributes of your services towards this intermediate. And it sits between one end, you have your API managers or developers. They created all kinds of services hosted in a VM, app service, service fabric, logic app, functions. And on the other end, you have your app consumers, which could be, applications or, a website, etc. So on one end, you have the people that try and create or abstract those APIs and put those as proxies inside, the intermediate, the gateway, which is API management. And then on the other end, you have your consumers that either try to explore what your API does or onboard those, etc. So you have your API on the right-hand side with a certain DNS or endpoint, and then you have your first and third party apps or whatever who wants to consume those APIs. So you can expose those, but then you can influence the name of your API. So it can have a different DNS type of name /foo, which is then the API itself. And this is the API which sits, on the Azure website and so forth. So you expose those. However, your proxy or API inside API management can have one or multiple operations pointing to different functions or logic apps. That's all possible. So you can have this composite service or API exposed to the first and third party apps. So this is the strength of this service. And what's interesting is once you do a request as a first or third party app, it will go through an inbound process going all the way back to the backend, and then the backend gives a response, and then it goes for an outbound towards those who call the API. And within those steps, so you have your outbound and your backend, you can place what's called policies. Meaning some of those quarterly attributes. You can say, okay, I want to restrict API the IPs. I'm only trusting traffic from this specific IP address. I can say, if you come to my API, you need to provide a token. This is more security related, and I will validate it against the identity server that the token is from. You can do some checks. You can, with a response, you can say, okay, the response is 10 fields, but I only want to return 5, and so forth. This is what those policies will do for you. So some of these things you don't have to program or do in your APIs. This is delegated all towards API management, and you can set those policies. And those policies, this is just a screenshot. You can do this in the portal itself. So you open up the portal, you create your API, you set some operations, and then you can do some processing, or at least you can set those policies on the inbound, outbound, or backend. If you choose to click the edit button, that's the pencil, then you can basically get to the the backend. This is kind of the behind. This is the file itself, the policy file, which is all XML based. All the policy are XML based. You can even input some code snippets with C#, and then again you see the inbound, you see your backend, you see your outbound, and even the on error, which is a placeholder for some errors that might happen in your policy and so forth. And what's important to know about these policies is scoping. So you have a global scope, which is just the whole API instance. It counts for every product API operation, and a product is just a container of your API, meaning that you can have a product with multiple APIs for a certain consumer. It will enforce the fact that every API will have a subscription key, which is an API key, to provide it at each API call operation and operation within that API. And looking at some of the policy, you can set some logging policies globally for everything. You can have rate and quota on your product. You can have a Java token validation or token validation on your API, and you can have cache and URL and body. So this is kind of the granularity around those policies with regards to API management. So if you do a get foo, which is the API, and bar is the operation, then it's hosted, the API is hosted, or at least the proxy is hosted in API management, and then you also have to provide a key if an API is a part of a product. So the product will enforce that, API key. The foo it's where your API takes place, could be Java token validation, and then you have the bar, which is the operation itself. Okay, pretty straightforward. So I talked about some of the characteristics which I think you need to know about. Integration tags, or the logic app with the connectors, Service Bus with messaging capability, eventing, which is important part, supporting real-time processing, and then of course the API management for some of the security related stuff. Going forward, you got this tag. I explained a little bit what this tag is, and then you have to create or an integration solution using these technologies, but there's more to it than just these tag around messaging, integration, and APIs, as you can see in the center part of this architecture building blocks diagram. You got to deal with security, you got to deal with automation, application lifecycle management, you got your infrastructure related to networking, but also the infrastructure supporting your integration solution. And on top of that, you need to think about monitoring and operations as well. So those are kind of, all your architecture type of building blocks. And within those building blocks, you can find different set of responsibilities with availability and disaster recovery and infrastructure, security with auditing, governance, kind of who you're going to give access control to, what kind of services, messaging with queuing, large messages, routing, reliability, your integration with workflow, exchange patterns, API scalability, governance, monitoring, reporting. There's tons of responsibilities listed here in this diagram. And if you plot this diagram, architecture diagram, on the capabilities Azure offers, you'll find those listed here more or less, like application insight and monitor with regards to operations, Active Directory for app registrations, supporting your API securities, Key Vault for some of your settings, Security Center, networking capabilities. When you have this ICE, have to deal with networks and subnets and etc. Messaging, integration. It also states data factory here, but it's more for data engineering. This is to do with extract, transformation, and loading, ETL type of processes. But yeah, you can also see it as a form of data integration. And then you get your APIs like functions, API management to kind of host the proxies for them and providing access to your functions or APIs. So this in total is your Azure Integration Solution Building Blocks diagram, plotted with all those services, each with their responsibilities. And I'm using that kind of paradigm with those building blocks with regards to my integration cases. And these are cases of solutions I created in the last couple of years. There's many of them, but I just chose a few of those. This is an on-premise scenario where there's a warehouse management systems and other systems on-prem that push data to a BizTalk server instance that does some mapping, and that's the only responsibility it has. It will push those workloads towards a HTTP logic app. So that means a logic app that has a HTTP connector. If you choose an HTTP connector and you save it, you will get this type of endpoint, which you can secure for your API management. So what you kind of can do is API management has this static IP address, which means that in the logic app, you will also say, I only trust this IP address. So you can pretty secure your logic app. A more secure would be if you have it in an isolated service environment or an integration service environment, I mean. It's being protected that way. The workload's pushed towards the Dynamics 365 endpoint where this processing of the workloads take place. And again, the endpoint of Dynamics is secured through API management. So in and outbound traffic towards the logic app is all secured. And then there's also an apply policy as an example here where you can do potentially some mapping on the outbound workload towards the Dynamics Finance and Operations endpoint. Currently, Dynamics is relabeled as Dynamics 365 Finance and Supply Chain Management. Okay, let's look at a more cloud native scenario. So this is where an event takes place in Salesforce, which leads to the fact that some of the data inside Salesforce from a certain entity needs to be pushed into ServiceNow. So what happens is Salesforce, an event takes place. It doesn't completely adhere to the Event Grid proprietary schema or cloud native schema, depending on what you would choose. So it does some mapping, but ultimately pushes that event to an Event Grid topic where there's this handler and other logic app listening to it. And the data elements of this event contains at least the entity and an ID of the entity that changed. And with that type of information, it will do a call to Salesforce. However, Salesforce doesn't just allow you to call it, so you need to provide a token. So with a certain policy in that API area, applying for each operation, it will first go to Salesforce, say, hey, provide me a token based on these credentials. And with that token, subsequent call is done to Salesforce saying, hey, I need this information from this entity. It will return some fields, and then you see another example of an outbound policy where it will map the response to free fields inside a JSON payload schema type of thing. At least it will have this default format, which what's called a canonical data format. So everything on the inside only talks one type of format, means that you have a complete decoupling of Salesforce and ServiceNow also on the data level. So this canonical, this payload is subsequently mapped again in another policy, and then it's injected into ServiceNow. Again with API management as securing the integration, but also the communication with those systems. And this is the interesting part. Going back to the Tower of Babel, all these systems kind of communicate differently, meaning their entities you can have an account entity in these systems, but some of the fields and the way they are named, it could be different. So you already need some type of transformation translation. So that's one thing. And then also the format, depending, it could be XML, JSON, flat file, depending on what the system communicate or how sophisticated these are. Of course, presumably you hope that the system communicate through REST and using the JSON format, but that's not always the case. So that's why you need this transformation. That's usually the center part or the core of integration. This is where that magic takes place, because this is what you need to provision. You can either use an integration account, which is a service in Azure allowing you to upload schemas and maps. So there's a little screenshot there in the middle, providing you some mapping capabilities. Or you could say, no, I'm going to push the payload to a function and say, hey, you do the transformation. Or you can do it even in API management policies. So that's all possible. And you could deal with different types of formats. So XML to XML, you could use XSLT. If it's JSON to JSON, you can use Liquid, or JSON to flat file, or vice versa. Similar to XML, you can also have it to flat file and XML. Or it could be custom.NET, that you serialize your JSON into an object, and then you map it to another object, and then you serialize it back to JSON. That's all possible. But this is what happens with this magic, with this transformation. This is the thing. Similar to if you talk English to someone else, if he understands, it's fine, but if he doesn't, you need to translate, see? And this is kind of similar. Okay, but there's more. It's not just a transformation. In general, when you build these solutions, you have to think about a few what I call best practice, the loose coupling, which is provided through Event Grid or the Service Bus. The other thing is monitoring. You have to have monitoring in place. You need to monitor end-to-end process or data that is being exchanged between those systems. It has to be event-driven when you look at near real-time processing, because the Service Bus always has this latency in it, right? You push a message and then you have to take it off. So that's kind of latency and a potential lot of overhead you might not want. The other thing is, because you're dealing with the cloud, you also have to think about cost management as well. And with regards to APIs and your solution, you need to think about versioning. Could be that you have version 1 for a certain process, but you also have a version 2 because another system talks differently, but you have to have both in place, so side by side. So this is where versioning is very important. Then you have governance, because you're exchanging data. That data could be containing some, information that is sensitive. So you have to think about that too, and who you're going to give access to the data. So and security is important as well. And automation, DevOps. So when you create those solutions, you want to automate the deployments of these solutions over multiple environments. So UAT and production. And with those best practices in mind, let's revisit, the scenario of the cloud native. So you have on top, you see this monitoring, because if you're building the integration solution, you probably have to collaborate or work extensively with an Azure admin. Access to Active Directory, or someone has to provide you an app registration and so forth. But also the Salesforce and the ServiceNow administrator will have a role in it, because they kind of have to provide access to those systems, and so have to set up stuff as well. Then in the middle part, you see that you have to deal with Azure monitoring stuff, with alerts and metrics, with regard to those services, the performance counters, cost management. You probably set up a budget for all your services, and if the budget is reached almost, you want to be alerted because potentially some service might consume too much resources. You want to look in that as well. You have API management, where you have to deal with identities and such. So you need, maybe you have to support OAuth 2.0. You have Key Vault for your secret management. With regards to Event Grid, with those subscriptions, Event Grid will also try to at least deliver your event, and it will try to do it again within 24 hours. If not, then the event is gone. But with a storage account, you can also support that lettering on those topics. And then with regards to API management, you have to deal with subscription keys. Those are the functions that you put in your product, APIs and policies. And then finally, there's also DevOps. So you have to think about ARM templating for your initial infrastructure. So like a custom event grid topic, presumably, or an Azure namespace, or maybe some monitoring stuff that you set up in your UAT and production environment using ARM template to keep it consistent. Similarly, your API definitions and your workflow definitions, those are your building blocks of your integration solution. Those need to be deployed using ARM as well, using YAML pipelines and such. With regards to monitoring, and let's revisit this other scenario with the hybrid one, again, you're dealing with the BizTalk admin, your Dynamics Financial and Operations admin, your Azure admin. Again, the operation part is pretty important. And then also the logging of the information going from the warehouse management system, operational type of data, or maybe it's financial data, all the way up to Dynamics. You want to monitor that process too, because it's pretty critical for your business. So the logging, as depicted in this picture, is being sent to this Service Bus namespace with queues of topics, and then all this logging is through a logic app being pushed towards Cosmos DB, which is a placeholder, or at least it contains all that event data of all your steps within your process, and then visualize it through a dashboard, which is interesting for a functional admin or someone that looks at the process as being done by having information from A to B, the process that takes place, and if something goes wrong, then someone gets a notification. Some of the other aspects in regards to this hybrid scenario, again, is monitoring, cost management, budgets, alerts, the security part with API management, as you can see, with policies. Again, also this hybrid scenario, you're dealing with automation. So automation of your infrastructure, automation of your API and workflow definitions using Azure YAML pipelines, but also the BizTalk artifacts, if there are a few, the packaging and deployment as well. And fortunately, there's a BizTalk deployment framework supporting that. So there's completely automation here as well. And automation also includes testing, etc. Okay, so I talked about Azure Integration Services, some examples, use cases, but there's another part in the Azure platform, not really Azure platform, in the Microsoft Cloud, supporting some integration capability as well, which is called Power Automate. And that's why I want to mention this too, because Power Automate is kind of the capability of getting information about really closed systems that don't expose an API or anything like that. So it's kind of a screen scraping type of technology where you record a task, automate the task, and play back the task. That's kind of what it does. And it's using Selenium type of technology. So you use what's called a UI Power Automate connector. You subsequently launch a recorder, record your click step, and then kind of build up your flow. Very useful if you're dealing with closed systems. And for this, I have a very small scenario where you see a tool which is closed, and it will look into a table, get the values, and put these into an Excel sheet. So this is all automated, recorded, and this is the type of integration you can have as well between one closed system and something else to get data from A to B. And there's a YouTube URL reference to a video created by Kent Weir, who has tons of videos around Power Automate and specifically the RPA capabilities, very interesting. And it's also a way of allowing systems to communicate, but in a different type of way. So that's why I'm also mentioning this here. And the other thing that's important to note is you can create Azure functions, either to be consumed in a Logic app or consumed in a Power Automate. So some of the capabilities that don't fit your Logic app or are a little bit too stringent or hard to do, you can delegate those type of capabilities to an Azure function. For instance, mapping. Okay, so finally, I want to look into a more holistic perspective of Azure Integration Service, the technology, the things I just discussed previously in all my slides. So one thing is Gartner, you all know Gartner, depicts that Microsoft is one of the leaders with its Azure Integration Services, or Integration Platform as a Service. This is how Logic Apps is being labeled. And similarly, there are other competitors in the space with Boomi, with Oracle, Jitterbit, some that offer similar capabilities, connectors and transformations and such. And since it released Microsoft GA Logic Apps in 2016, and some of those other systems were present as well, and a year later it became one of the leaders, and it's been subsequently a leader for years now, and this is one of the latest quadrants, meaning that it's serious tech. Although you might think a drag and drop and stuff, and maybe it doesn't really appeal to a developer, you can refer to using durable functions for your workflow, but in a lot of cases, it's not really suited for integration type of scenarios. So that's why Logic App fits in. Similarly, if you look at API management, which is another tool and capability or service within the Azure Integration Services, as standalone, you can use it, but it's very useful in integration scenarios, which I showed you. It's also a leader now since last year. There's other ones like Apogee, which is now part of the Google Cloud Platform. You got MuleSoft, AG, IBM, Kong, which is an open source API management tool. So also Microsoft is now one of the leaders in this quadrant. So that's very interesting to know that, most of the Azure Integration Services are very evolved and mature service capabilities and on par with some of their competitors. And similarly with low code, where Azure Power Automate is part of a low code platform, it's also one of their leaders as well, with Mendix and OutSystem providing stuff as well. The low-code application platform is not just Power Automate, but also Power Apps. Okay? Right, going forward, what are the takeaways? What is kind of my message? So depending on your scenario, choose the right technology. So it's all based on the requirements with regards to your integration solutions, allowing systems to communicate with each other. There's tons of technologies, Power Automate, durable functions, Logic Apps, Event Grid, Service Bus, but none of them are competing. You can use these simultaneously or use them inside your integration architecture. So I've showed you some example where these technologies are part of a complete integration between systems. What's really key, I want to stress, is that you need to understand the tech. So that's why I dove a little bit into the technology of Azure Integration Services. But you have to understand the processes, but also the non-functionals, because those are key with regards to your solution. For instance, if you look at Logic Apps, you can either have this isolated, so you can also have VNet support, or you can even containerize it going forward if the Logic App Preview, which is the next iteration of Logic App, becomes available. And the other thing that's really important is that you have to apply the best practices and leverage Azure Well-Architected Framework, which was released a few months ago, providing you some guidance as well with regards to the stuff I mentioned with security and so forth. So really keep those in mind. And finally, there's some source to explore. You see a nice picture of Verona. I haven't been there, so I like to explore, so maybe one day I will go there as well. But with regards to the integration services, there's a ton of stuff as well. There's an architect framework, there's a coded blog, which is one of the companies really diving into integration as well. You got your integration patterns. Microsoft Learn is a good one for all these services to explore and learn as well. There's serverless notes where you can find some information around these services as well. Okay, so I'd like to thank you. This was a pre-recorded session, but anyway, if there are questions, you can always reach out to me through Twitter, for instance, at Stevian, or contact me through LinkedIn, or you can look at some of the resources. Also, some of the slide decks around this topic are available on GitHub as well. So I've done this talk before, but anyways, thanks. Enjoy the Global Azure Bootcamp, and goodbye.